Hi, today we're going to talk about design patterns. We'll cover topics such as what are design patterns, where are they used, and why do we need them. We'll also cover a case study on singleton design pattern and look at some of the trade-offs we need to consider before using it. So let's start. So what are design patterns? According to Wikipedia, they are a general reusable solution to a commonly occurring problem within a given context in software design. I'll add more on that to say these solutions are developed keeping in mind object-oriented programming and solid principles. So we'll cover these principles in details later. So as a summary, these are the existing famous solutions to commonly occurring design problems. So that leads to us to our next question. Where are they used? So design patterns are used in all of the object-oriented programming languages. So what do you mean by an object-oriented programming language? So the basic notion here is that everything is an object. An object is something that at least has a state or a behavior. So take for example, your bank account, which has the current balance as a state and it exhibits a behavior of transferring money. Examples of OOP languages are Java, Python, and JavaScript. So let's move to the next question. Why do we need them? Design patterns help us develop maintainable code and are of utmost importance in designing scalable architecture. And moreover, they are like a common language among experienced developers. So keeping a keeping a code maintainable is utmost importance as we go further, making the application more scalable and like even converting to different architectures such as microservices. Okay, so but one question that must be coming to your mind is like, from when did we know the design patterns as we know them today? Okay, so the design patterns were identified formally by Gangs of Four, which is ideated to the four people who identified it. They have quoted almost 24 design patterns and divided them into three categories, namely creation, structure, and behavior based on the aspect of the problems they deal with. Oh, history, I hate it. Today we'll cover one of the famous of all those, singleton design pattern, which is a creational design pattern. So what do we understand by creational and singleton? So creational says to create instance or instantiate something. And singleton means a single instance of that something. So a singleton is limited by its scope. So the scope of singleton in Java is class loaded and scope of singleton in Spring is an application context. But wait, why would we need a singleton? So the use case of singleton could be as simple as saying we need a singleton when we need a single object. For example, having more than one thread pool or DB connection pool for an application does not make sense, right? So the alternative use case of singleton can be as difficult as saying singleton is used where we need to guarantee a lock-free, consistent, or efficient access to a resource. But wait, what is this resource? So a resource can be a file, a database, or even a thread pool. So, but would we ever need the guarantees such as lock-free consistency or efficiency? So let's talk about the famous logger instance. An event-based logger service acts as a single event source to which multiple classes can register. So would the classes need more than one instance? No. What if they had multiple instances publishing to the same logger file? So the file level logs comes into picture now. File locking mechanism cannot guarantee the lock allocation on a first come first served manner. Moreover, there may be inconsistencies where one instance could be interrupted by another instance in the midway before completing the line, leading to distorted file. Similar is the case with configuration properties file that is read at the start of the application. So you won't need like multiple instances for those things. So the scope of a logger file here, logger object here would be to us log file. So one logger object for one log file, and another logger object for another file if there exists another file. Okay, so here we discuss like how being lock free and consistent logger instance helped us in the long run. Okay, so for studying Singleton's effect of efficiency, we can take the case of session factory. Instances of session factory are thread safe and typically shared throughout an application. As these objects are heavyweight because they contain the connection information, hibernate configuration information, mapping files, location path, creating a number of such instances will make our application heavyweight too. So creating a single instance can suffice the resource requirement as well as increasing efficiency. So here we only require a single instance of the same file. So this also helps us increase the efficiency. So the scope of session factory here is one session factory per data source. So if you're using two data sources, if you're using two databases, you can have two session factories, but they should be one session factory per data source. Okay. So as we have gathered all the functional requirements that are required to make Singleton, let's summarize them. So the first thing that we require from Singleton is a global state. So what should be so the Singleton instance should be accessible globally over the application, over every instance of the application. And the second thing is it should be immutable. So a singleton instance could not be mutated or could not be changed. The state of the object could not be changed by some class or subclass or superclass. The third thing is it should be thread safe. If we're using multiple threads in our environment, so it should not break the singleton property. Okay, as you've gathered these functional requirements, let's move to the code.